Hi, folks. It's good to see you again. Well, actually, I can't see you, but you can see me, so I guess it'll have to do. We are today looking at solving equations. This is very much the sister chapter to our previous one about expressions, because you see, an equation is actually just two expressions that equal each other. We did touch on this a little bit in our last lesson. So we're going to be looking at some examples of how to write those equations, solving one-step equations, both with addition or subtraction, or multiplication or division, and then how to solve two-step equations when you have both of them there. Okay, so let's take an example here. Let's talk about apples, shall we? Apples are always a great thing to talk about in math. I have an unknown number of apples. You'll find out how many apples I have later, but hold your horses there, buckaroos. So our variable here, let x equal my original number of apples. Because something is going to happen. Someone's going to give me some apples. A mysterious dark stranger. They are going to give me 3 apples, and now I have 17. 17 apples. So this is how you would write it. X plus 3 equals 17. My original number of apples plus, here we go, plus 3 equals 17 apples. Wonderful. So the question is, solving an equation, how many apples did I have in the first place? What you have to do in any equation is to perform what's called the opposite operation. If you have addition, the opposite operation is subtraction, and vice versa. If you have multiplication, the opposite operation is division, and vice versa. So in this case, if we're adding 3 to x to get 17, we are going to subtract 3 from both sides. Okay, this is what it will look like. So x plus 3 minus 3 equals 17 minus 3. So whatever you do to one side, you have to do to the other. Otherwise, both sides won't be equal to each other, and it's no longer an equation. So x plus 3 minus 3, the plus 3 and the minus 3 cancel out. The 17 minus 3 on the other side equals 14. Okay, so therefore we have 14 apples that we had originally. The beautiful thing about equations is you can check to see if you are right. I mean, especially as they get more complex, mistakes can happen. And so the way you check your work is simply substitute your answer for x or whatever variable you have in for the original variable at the beginning of the equation. So this is what it will look like. So I've taken the original equation of x plus 3 equals 17 and I've substituted in 14. And now these brackets mathematically are not required to do the operation because they're just around one number, but that shows us that it's substitution. So it is a proper thing you want to include. So we see 14 plus 3 equals 17. 17 equals 17. Therefore, we know that 14 was the correct value for x. Okay? If it was, let's say for example, the stranger took 3 apples from us and now we had 17, it would be x minus 3 equals 17. We'd have to add 3 to both sides, and it would be 20. It would be 20 instead of 14, because we're adding then instead of subtracting. Okay, so that already takes us to all the way through our second topic in the chapter, which was 11.2 about one-step equations of addition or subtraction. We're now going to look at what does that look like with multiplication or division. So let's say we're buying something. We're buying loaves of bread. Every loaf of bread costs $5. But how many loaves of bread do we have if our total bill was $25? I've been dying to know. Let x equal number of loaves. So if every loaf costs $5, we're going to multiply the number of loaves by 5. By $5 equals $25 in total. So now we need to figure out how many total loaves do we have. So in this case, multiplying each side by 5, you are going to divide each side by 5 to get x by itself. This is what it will look like. So divide by 5, divide by 5. Now, if you're multiplying and dividing it by 5, as we are on the left, it cancels itself out. Because it's basically like you're then multiplying or dividing it by 1, which is just the same, not going to change the number. Okay? So x, we just have x on the left side and 25 divided divided by 5 equals 5 on the right side. So therefore, we have 5 loaves of bread. And I'm writing this out as a sentence because that's what you do in math, in a word problem. We have 5 loaves of bread. Now, once again, if you want to check to verify that, you can plug in 5 for the x. 5, you'll see 5 times 5 equals 25 in your original equation. Okay, so let's take a look at division, and then we're on to our real doozy, which is the process of solving two-step equations. Okay, so let's use this side here. Okay, so in this case, let's say that I have some carrots and I have some bunnies, and I'm going to feed the carrots to the bunnies. So I have an unknown number of bunnies. I haven't checked how many they've had since breeding season, right? Let x equal number of bunnies. So x, and I'm going to, the question is, if I give each bunny 5 carrots, oh, no, sorry. If I divide the bunnies, let's say I'm dividing them in different carrot fields, and so that I have 5 different carrot fields, and the bunnies, being very orderly, are all going to be evenly distributed. X divided by 5. Each field, I notice, has 10 bunnies in it. Okay, so this is what it looks like. X divided by 5 equals 10. So we have 5 fields. Each field will have 10 bunnies. Okay. So we want to get, once again, just get x by itself. That's how we solve for our unknown. It's currently divided by 5. We are going to multiply it by 5. Each side of the equation, that is. This is what it shall look like. So you'll notice, once again, we have both multiplication and division of the same number with the variable, with the x. And then we have 10 times 5 on the other side. So the times 5 divided by 5 cancel out on the left, so it just becomes x. 10 times 5 on the right becomes 50. X equals 50. Therefore, we have 50 bunnies in total. Take a look at this. Yeah, we have 50 bunnies in total. Okay, and so you want to substitute that. You would just plug in the 50 for the x right here. 50 divided by 5 equals 10, and you see you're correct. Okay, so some questions get a little more complex, and you may end up having 2 steps. That's what chapter 11.4 gets to. We're going to get some fresh paper here. Okay, fantastic. So let's talk about hosting a school dance, shall we? And we're looking at how much, if we are giving away tickets, let's say we're not charging any money, it's going to be free, but we're going to see how much will it cost. If we have $1,000 and there are certain fees that we need to pay first, how many students can we afford to have at this dance? Okay, so we're going to say let x equal our number of students. And of course, in a real school dance, you charge ticket money, right? You have to pay for it somehow. So x, and each student is going to, it'll cost $5 worth of refreshments and treats and things like that for your students, but it's also going to cost $300 to hire a DJ. And so we have $1,000 right here in our account. So $5 for a certain number of students plus $300 for the DJ equals our total budget we have. How many students on this budget can we afford? Okay, so in this case, when we're doing these opposite operations, it's the reverse order of bad math. We have to do our addition or subtraction first. You might wonder why. The reason being that if you wanted to divide this by 5, well, you could, and we can actually have a little bit of an experiment with that after this, but you'd have to divide, if you're dividing both sides by 5, you have to do the entire side. You can't just divide the 5x yet. You have to divide the 300 as well as the 1,000. We'll take a look at that and see if that works afterward, but it is messier, and you'll see this is a lot simpler. Okay, so 5x plus 300. We're going to get rid of that plus 300. So minus 300 equals 1,000 minus 300. Okay? So on this side, it'll just cancel out. So that becomes 5x equals 700 right here. So now it's just, once again, we're in comfortable territory. It's a one-step equation. Divide each side by 5 to get the x by itself. Divide by 5, divide by 5, it becomes x equals 140. Okay, so we should be able to afford 140 students. Before I go and write the sentence for that, let's plug that in to the original equation and see if we are correct. That's the beautiful thing. You can basically mark your own test to see if the equation works on both sides by substitution. Okay. So you see what I've done here is I've gone original equation, 5x plus 300 equals 1,000. I've replaced the x with 140 plus the 300 equals 1,000. Okay, so 5 times 140 equals 700. Plus 300 equals 1,000. Therefore, 1,000 equals 1,000. We are correct. Isn't that fantastic? And therefore, we can afford to have 140 students. Okay, it's tough to write and look at a different direction at the same time, but I'm a professional. That's what I do. Okay, so question is, now what happens if we wanted to do that division first? This could be a little tricky, but we'll see if it turns out the same way, okay? So 5x plus 300 equals 1,000 again. Okay, so we're going to divide everything on one side by 5, divide everything on the other side by 5. This is going to be kind of weird. Okay, so we're going to go divide the 5x by 5 and divide the 300 by 5. This part will be easier because it's just going to be 200, right? Okay, so 5x divided by 5 should be x. 300 divided by 5 should be 60. And the 1,000 divided by 5 is 200. Okay, so now we have x plus 60, and now we're going to be subtracting 60 from both sides, right, to get rid of the 60. So x plus 60 minus 60 equals 200 minus 60. And take a look here. Take a look here. We actually got the correct answer doing it the other way. So yeah, it is technically correct. But the thing is, especially as you go into later grades, your questions, your equations get more and more complex. And it's just so much easier with the multiplication and division to just do it for one number. Just, get your addition and subtraction out of the way. You are doing less math by getting rid of the addition or subtraction first, right? Because you're still having to do that, but we are only having to divide one number. Okay, so just to give you another example, I'll just give you another example of a two-step equation, and I'm not even going to bother making it a word problem. I'm just going to give you the equation. We're going to go with x divided by 50 minus 4 equals 32. Why not? Okay, so we need to solve for x. Now, one of the things with word problems, honestly, one of the tougher parts of the unit is not even all these steps. It is when you see a word problem, identifying what will that look like as an equation. So, you thought you could escape reading comprehension in math. No, you really can't. Because you have to see, okay, what is actually happening then to these numbers, and what does each number represent? Okay, so once again, we're going to just take the easy way first. We're going to add 4 to both sides to get rid of the subtraction. So x divided by 50 minus 4 plus 4 equals 32 plus 4. Okay, so that becomes, the minus 4 plus 4 cancel out. X over 50 equals 36. Ooh, I should have given myself smaller numbers. Oh my goodness. X divided by 50 equals 36. So to get x by itself, all we have to do now is multiply each side by 50. Not so hard, right? Okay. So we cancel out, and it's going to be x equals 36 times 50. And what is that? Let's see if I can quickly do that in my head. It is that would be 1,800, I think, right? Sounds about right. But why not confirm that by putting it into the equation and solving it? Okay. So I'm going to go with the original one. 1,800 divided by 50 minus 4 equals 36. Okay. So 1,800 divided by 50 comes out to be 20, 30, 36. Wait a second. Hold up. Hold the phone there. 1,800 divided by 50, that is 10, 20, 30. Oh no, hold up. I made a mistake here. Sorry. Look. The original equation was equals 32. I thought, oh my goodness, I failed. See, this is where you have to look very carefully here. Okay, so sorry, 1,800 divided by 50 minus 4 equals 36. Sorry, 1,800 divided by 50 is 36. Oh, that was close. Okay, 36 minus 4 equals 32. That is correct. So we know we were right there. X equals 1,800. Okay. So 32 equals 32. How lovely. Okay. So now I'm going to show you one more thing. This is almost like a bonus. You probably won't see any questions that are like this in your textbook, but it's good to see this just so you're not intimidated. Let's say, though, that we have the x on the bottom. Let's say we're doing a division. We have a number. We say 150 divided by x equals 3. So you might know 150 divided by 50 is 3, right? That's one you can do in your head. But let's go through the steps. In order to get x by itself, now x is on the bottom, instead of multiplying both sides by a number, we're going to multiply both sides by x. Okay? And so we're actually going to get rid of x on one side and see it reappear on the other. So 150x divided by x equals 3x. So take a look here. We've multiplied both sides by x. I didn't write the multiplication symbol because when there is no symbol at all, we know it's multiplication. So that cancels out on this side. So 150 equals 3x. So now to get x by itself, we're going to divide each side by 3. Therefore, 50 equals x. So yeah, you might see x on the bottom. And that's no problem. You just need to get it to the other side of the equal sign. Okay, so that ends our second last unit. You can get right to it. I will have a unit test up pretty soon. Email me with any questions. We're getting close to the end of the year, and it's a good feeling, isn't it? Okay, enjoy the flowers, and I'll see you later.